Dear students, welcome to my YouTube channel PCM Academy and myself Prasenjit Mallik, M.sc in Physics. We are in a lecture series for IIT JAM Mathematical Physics. In the last class, we have discussed something about matrices. Okay, and the class was basically for eigenvalue and eigenvector, and we have discussed some basic concepts of eigenvalues and eigenvector. So, if you are new in this channel, please subscribe my channel and hit the bell icon also to get the further notification. If you are preparing yourself for IIT JAM, Jest, NEet, get these kinds of competitive exams based on physics, then this channel will be very helpful for you. Okay, so let me start the topics that we have already discussed in the last class, that is eigenvalues and eigenvectors. Okay, so today I will discuss about something about C.H.Theorem, that is Cayley-Hamilton theorem also, and we will solve one problems so that you can understand how you can find out eigenvalues. Okay, so let me take matrices, 2 by 2 matrices first, then we will move to 3 by 3 matrices also later on. So let me first take a matrix A. Okay, suppose this is A and the matrix is minus 5, 2 and 2 minus 2. So suppose this is your 2 by 2 matrice, and we have to find out the eigenvalues for this matrix first. Okay, and obviously you have to find out the characteristic equations also. So we have the characteristic equation, that is A minus lambda I determinant is equal to 0. Now if you want to solve this equation by using this equation, A minus lambda is equal to 0, then what you have to do, you have to write this equation in this way, that is minus 5 minus lambda, 2 and minus 2 minus lambda. So this is your determinant and you have to put this equal to 0. Okay, so now if you solve, you can find that this will be nothing but, you can write it as 5 plus lambda. If you take common here minus, then you will get these kinds of things. So it will be your 5 plus lambda into 2 plus lambda, and this minus will be cancelled out if you multiply this two. Okay, so you will get from here that you have lambda plus 5 into lambda plus 2, okay, and minus 4 equal to 0. Minus 4 equal to 0. So now if you want to solve it, so let me solve it. This will be lambda square plus 7 lambda plus 10 minus 4 equal to 0, that is lambda square plus 7 lambda plus 6 equal to 0. So this is your characteristic equation, and you can say this is f of lambda is equal to 0, and the roots of this equation, that is lambda square plus 7 lambda plus 6, is nothing but the eigenvalues of this matrices. Okay, so if you want to solve this equation, then you will get the eigenvalues of the matrix. But let me tell you one thing, that this characteristic equation satisfy, instead if you put, instead of lambda, if you put A, that is the matrix itself, then it will satisfy also f of A is equal to 0. That means you can write this as a lambda square plus 7 lambda plus 6 equal to 0. From here, if you put instead of lambda A, you will get this A square plus 7A plus 6I equal to 0. And this theorem, that the characteristic equation also hold for the matrix itself. This theorem is nothing but the C.H.Theorem or Cayley-Hamilton theorem. This is known as Cayley-Hamilton theorem. And this principle is very useful if you want to find out inverse of this matrices from here. Okay, so if you want to write this equation in this way, that is here is A square plus 7A plus 6I equal to 0. Now if you write this equation in this way, because your I will be A inverse. Okay, so it will be A square plus 7A plus 6A inverse equal to 0. So it will be something like this. Then if you want to find out the A inverse, then you have to put like this, 6A inverse equal to, it will be your minus 7A minus A square. So your 6A inverse will be minus 7i, okay, minus a. So your A inverse will be from here 1 upon 6 into minus a minus 7i. So from this equation you can find out the A inverse also by only using this operation, and this is simply a matrix addition operation. Okay, so you can find out from this equation by using C.H. theorem. Whenever you are given a matrices, you have to find out first the characteristic equation. This characteristic equation will hold for the matrix itself. Now from here you can find out A inverse in this way. Okay, so this is another way of finding out A inverse by using simple addition operation of matrices, and you know the addition operation of matrices is always easy. Otherwise you can find out A inverse by using adjoint A divided by determinant A, but that will be sometimes very lengthy process. But if you use this C.H. theorem, you can easily find out the A inverse. Okay, now let me tell you about the eigenvalues. Okay, and if you solve this equation, you will get eigenvalues easily. Okay, so if you solve this equation, that is lambda square, if you take this 7 lambda as 6 lambda plus 6 equal to 0, so you will get this lambda into lambda plus 6, okay, plus 1 into lambda plus 6 equal to 0. So you will get from here that lambda plus 6 into lambda plus 1 equal to 0, and from here you will get two values of lambda, one is minus 6 and another is minus 1. Okay, so you have two solutions. Obviously this is the quadratic equation in 2 by 2 matrices, and as expected you will get two values, one is minus 6 and one is minus 1, and these are the eigenvalues. These are the eigenvalues. These are the eigenvalues. Eigenvalues. Okay, and you can verify the result that I have discussed in the last class, that two important theorem about the eigenvalues, that if you take the addition of these two eigenvalues, that is lambda 1 plus lambda 2, if you take this as lambda 1 and this as lambda 2, now if you add these two, that is lambda 1 plus lambda 2, so what you will get? You will get this as minus 7, and if you take the trace of the matrix, you can see this is also minus 7. So I have told in the last class the important theorem that the sum of the eigenvalues of the matrix is nothing but the trace of the matrix. Similarly, if you multiply these two, okay, minus 6 into minus 1, that means lambda 1 lambda 2, so you will get 6 plus 6, and that is nothing but the determinant of this matrix. You can find that 5 into 2 10 minus 4, that is also 6 plus 6. So this is nothing but the determinant of A, and this is nothing but the trace of A as expected. Okay, now we will discuss how you can find out the eigenvectors for the corresponding eigenvalue lambda 1 and lambda 2 for this matrix. Okay, so our next task is to find out the eigenvector for this matrix for the corresponding eigenvalue lambda 1 and lambda 2, that is minus 6 and minus 1. Okay, so we will discuss this thing in the next class. Okay, thank you.